Welcome back, everybody. Today we got a lesson on erosion by wind. So we'll start off here with a nice photograph showing the Great Sand Dunes National Park in southeastern Colorado. And you can see my kids in the foreground, and way up near the top you can see some people climbing up to these massive dunes, all eroded by wind. And there they are sliding down one of the slip faces. It's a fun place. So first off, wind doesn't erode large particles. Sand is about the largest size that can be picked up and carried by the speed of wind. So anything sand-sized, silt-sized, and clay-sized can be eroded by wind. Wind erosion generally, as a rule of thumb, occurs in arid regions, dry regions, or on coastlines where there's dry sand available to be blown around. Couple types of wind erosion. One of them is called deflation. Think of a tire losing its air. It's lowering as it does so. Deflation is how certain places that have lots of wind erosion appear after the sand has disappeared. The ground looks like it's literally lowering, like a flattened tire. And many rocks will take on a sandblasted or frosted or pitted appearance after erosion by wind and windblown sand. And that's simply a form of abrasion, which we've learned about with water erosion. And there's the definition for deflation: the lowering of the land produced by wind, eroding loose sediments, leaving only the rock protected sediment behind. And you can see in this picture on the right-hand side, plenty of grass here, and the roots from the grass are doing a pretty good job of holding the soil together. So there's actually some thickness to the ground there underneath the roots of the grass. However, over here in this area, you can see the soil has been deflated, literally picked up and moved somewhere else. And so it looks like the whole ground has lowered down like a tire deflating. You can see some other areas where it's being held together by the roots of plants, but other areas where it's being deflated. So vegetation is actually a really crucial part to preventing deflation. Small sediments, if they are blown away and only the larger ones are left behind, can create something we call desert pavement. And desert pavement's called that because it's like a gravel road. I mean, you can practically drive on this stuff. Wind can only lift sand to about 1 meter. And because of this, you only get about 1 meter off the ground, maybe a little higher in some places, where the sand can actually start eroding away and abrading the rock. And so you get these mushroom-shaped rocks, pretty cool in appearance because of that. You also get rocks called ventifacts. It's called that like ventilation, air is involved. And it just kind of rounds them off, but you'll see little frosted and pitted type appearances, like sandblasted glass, like frosted glass, but in rock instead. So those are a couple characteristics of sand eroded rocks. Here's a beautiful shot of a couple mushroom rocks. So you know that this distance here is about 1 meter or so high, because that's about as high as wind can pick up and carry sand. And so the sand grains never make it up, not never, but they rarely make it up higher to erode the upper parts. And so eventually this section will fall, will crumble, and that boulder will fall to the ground. The cross-section below shows the movement of wind-driven sand particles that strike a partly exposed basalt cobble located at the surface of a windy desert. And so you can see the sand grains are bouncing and sliding along here. They're saltating, and they bang into this rock. They abrade this rock. And over time, what's going to happen to the basalt cobble? They want to know which picture would it look like. And it's going to smooth out this area on this side, but leave this area relatively untouched. And so the best choice would be 3. That's your ventifact, which, remember, is just the name of a rock that's been eroded heavily by wind. Now, this is the same picture we saw before, but the question above is different. Wind erosion occurs mostly in arid climates, dry climates, and why? And we know that, around here, if it's a really, really dry summer, you definitely have soil that's a lot lighter. You can see the dirt roads, all the dirt flies up when cars drive down the roads. But after a rainstorm, that doesn't happen. Water tends to keep the dirt or the soil heavy, and that keeps it from flying up in the wind. Takes many forms. Here are some dust devils. We get the same thing around here with leaves in the fall. Another question. Picture below shows a geological feature in the Kalahari Desert of southwestern Africa. Which process most likely produced the present appearance of this feature? And they're talking about this feature right there. And of course the answer is wind erosion. And you can see at one point back in time, that was only about a meter off the ground. This has probably been deflated over time, this area, but there's your mushroom-shaped rock. Okay, moving on to sand dunes. Dunes are produced when the wind blows sand against some kind of object. It could be a small object in the sand, like a shrub or a rock or something, and that builds up sand on the windward side and creates what we call a dune. Now this here is a particular type of dune called the Barkhan dune, and it has this kind of horned appearance to it. The wind is coming from the left towards the right, and you'll see it's pushing off these horns on both the top and the bottom. And this is the slip face, the steep part on the back side of the dune, and this is a much more gentle back slope of the dune. And the whole dune will migrate over time to the right in this case, if the wind direction stays the same, predominantly. So here's a side view of that same dune. We got the windward side on the left. The wind is blowing the sand grains up, and then they fall down the slip face, the steeper side on the back, and this whole dune gets moved. And it shows it building up here, building up here. It will continue to do so, and you'll get more and more build up like this, and this will erode away here. So the whole dune will move over time, in this case again to the right. Now here's a photograph of the Great Sand Dunes National Monument in Colorado again. And the question is, which way are the dune fields migrating here? Which has to do with the prevailing winds. So if we just kind of map out one particular dune, here's a nice one over here. Can you see how there's a steeper side on the right and a less steep side on the left? This is your windward side, and this is your slip face side, the leeward side. So the wind is coming from this direction, and it's moving the dune to the right. And we can actually watch this happen. So the wind's carrying the sand, it's moving it off to the right. Wind changes direction, perhaps another point in Earth's history, and creates this cross-bedding appearance, which we'll talk about in the next unit. This particular applet's showing the same thing underwater. And that's about it. And we're not going to go through this today. So hopefully you guys learned a little bit about wind erosion. And see you next time.